Here we have a word problem, and we're talking about U.S. internet advertising revenue. That's not something I'm super familiar with, but I see that I'm given a rate. It says it's increased at the following rate, and it's even labeled like a derivative as rates of change should be, and then we're going to a total R of t. So if you're going from a derivative back to an original, all you're doing is solving an initial value problem. So when we're doing word problems with these antiderivatives, it's probably just an initial value problem. So I want to remember, if I'm given a derivative and I'm asked for the original, then I need to do my 3 steps to solve an IVP, an initial value problem. So our first step, just to review, because we did this with the first section where we first learned antiderivatives, what we did to solve an initial value problem, first thing we did was we were to take this antiderivative, then that ended with a plus c, so the next step that we did was we found what c was. So we're going to take the antiderivative, we're going to find c, and then our third step isn't really a step, but we don't want to forget it. We're going to write our final answer, that equation that we found from the antiderivative and the c value. So I'm going to keep calm with this unfamiliar setup. If I have a word problem, it's probably just an initial value problem. So we have the U.S. internet advertising revenue in 2002, which is our time 0, was $5.2 billion. So initially they already had $5.2 billion in revenue from advertising on the internet. Since then, the advertising revenue has increased following the rate, this R prime of t, and it's in billions of dollars per year. So I know the rate at which this revenue from advertising on the internet is increasing, and I want to figure out what's the net revenue that we're getting in a given year t. So I want to find this R of t, and I'm given R prime. So the first thing to get from R prime to R is we're going to take our antiderivative. So R of t is going to be the antiderivative of this R prime. We're going to take the antiderivative of 0.84t plus 1.12, and then we need a dt in here because it's with respect to time. So I'm going to integrate as usual. I'm going to add 1, put it in the denominator, put it up top. So I'm going to have 0.84 divided by what? Well, this is t to the first, so 1 plus 1 is 2. And I have t to the 2. Plus the antiderivative of this constant, 1.12, is going to be 1.12 t. And then we would write plus c. So we know it's a plus c instead of a valuation bar because we don't have any bounds on our integral. It's an indefinite integral. All of our answers end with a plus c. So my second step is to figure out what is this value of c. So I'm either going to be given a point. If it's not a word problem or in a word problem, I just have to figure out either using common sense or what's given to me. So I want to figure out the initial value c. Could there have been any revenue in this time 0? Does it say initially there was no revenue from advertising on the internet? No, the first year, this initial time where they started advertising on the internet, they already had 5.2 billion. So we are given C. I actually like the word problems a lot better than the non-word problems because we don't have to do much work to find C. We don't have to work with any crazy fractions or anything like before. It's given to us what the initial value is, or we can think about it. A lot of times with revenue, if we're selling something, for instance, if we're selling t-shirts and we've sold 0 t-shirts, our initial revenue is 0, and it might not say that in the problem, but we can figure that out using common sense. So a lot of times the initial value with revenue is nothing, because if you sold nothing, then you get nothing. But here we're not selling things, we're talking about years, and in year 0 there really was a revenue already, so we do have an initial value. So either you can use common sense, or it's written explicitly for you if you couldn't just figure it out. So my last step is to write the equation. I'm going to simplify this because 84 divided by 2 is going to give me 0.42 t squared plus 1.12 t plus my c value is 5.2 for that initial value. Here's the original revenue function that has this for its derivative, R prime, and you could check if you weren't sure, especially if you're doing a test or something and you don't want to submit yet. I would take the derivative of it, make sure you get back to R prime, and also if you plug in R of 0, if you plug in times 0, we really will get that 5.2 billion out. So it should be correct. Part B says, if the trend continued, what was the internet advertising revenue in 2009? So first thing, let's figure out the t value for 2009. And this is where you can definitely count on your fingers if you have to. 0 is 2002, so 1 is 2003, 2004, 2005, 2006, 2007, 2008, 2009. I'm counting on my fingers right now, and I got t equals 7. Okay, so the question is, are we plugging into R, the equation we found, or R prime? So are we asked for the total revenue, or are we asked for how fast it's changing? Because this is giving us the total revenue. This is how fast the revenue is changing each year. Well, I don't see it saying how fast was the internet revenue changing in 2009. It's saying what was the internet advertising revenue. This is going to tell us what it was. This is going to tell us the rate that it was changing. So we want to plug into R. We want R of 7. So we're plugging into what we found in the first step. So we're going to do 0.42 in our calculators times 7 squared plus 1.12 times 7 plus 5.2. And the answer we should get is 33.62. And then I want to think about what the units are on this. So I'm talking about revenue. So this is money. Is it just $33.62 made in year 7? No, we want to remember we're talking about billions of dollars. So in 2002, the revenue was $5.2 billion from advertising on the internet. And then we knew it was increasing because it says this is increasing at this rate. So by 2009, we went from $5.2 billion in 2002 to $33.62 billion in revenue from advertising on the internet in 2009.